There are multiple areas of MaxScript and 3ds Max that operate with so-called barycentric coordinates. Let's see how these coordinates are calculated and used to interpolate between three known values. Let's look at the triangle, a triangular face with three vertices. This is vertex 1, vertex 2, and vertex 3. We're going to mark the corners, the three vertices of this triangular face, with a red, green, and blue sphere, where the red sphere corresponds to vertex 1, the green to vertex 2, and the blue to vertex 3. Looking at the results of the getFace function, the first face is defined as the list 3, 1, and 2, which means that the blue vertex is the first vertex from point of view of the face. The actual first vertex, the red one, is in fact the second vertex in the face, and the second green vertex is actually used in third place in the face definition. This is important to note because when we calculate the barycentric coordinates, the corresponding values are going to be shifted according to the face definition and not the indexing of the vertices inside the mesh. Now let's take a fourth point in the same plane as the three vertices. That means in the plane of the face itself. And let's connect this point with the 3 points, the 3 corners of the triangular face. As we can see, these lines divide the area of the whole face into 3 subtriangles. The barycentric coordinates are calculated by calculating the full area of the face, the small triangular area, and then dividing the small one by the full area. If we take a look at the resulting barycentric coordinates, we can see that if we would align our points to the first vertex in the face, vertex number 3, then the first barycentric coordinate is taken as 1 and the other 2 as 0, because the area of the small triangle is the same as the full area. So the one divided by the other results in 1, and the other two triangles are non-existent. In this case, they are both 0. They have an area of 0, so the results are also 0. If we would move the point back, the areas of the other two subtriangles become non-zero. It's important to note that the sum of the 3 values is always equal to 1. We can select this text and take a look at the sum of the 3 components. As expected, the sum of the 3 components, the 3 barycentric coordinates, is 1.0. The same is true for the other points. If we would align the fourth point with the second vertex, the second barycentric coordinate becomes 1. And if we would align the fourth point with the third vertex, the third barycentric coordinate becomes 1 and the other 2 becomes 0. Obviously, the area of the subtriangle on the opposite side of the vertex provides the barycentric coordinate for that vertex. The barycentric coordinates in MaxScript can be calculated using the mashup method getBaryCoords from a mesh object